All right. Wait. Why am I hearing? Oh, that's my video. Okay. So, let me check. Let me do a mic check with what's their name? YouTube. YouTube mic check. Sounds okay. Sounds okay. I don't want to touch the settings so much, but I noticed that my audio is a little bit too high. I'll reduce it. Instead of 200%, let's reduce it to, it's now at 157. Okay. All right. So the two observers paradox. So what do I mean by that? Well, it's the normal paradox. Two people, right? According to special Einstein's special relativity, two people can each claim to be stationary and can claim that the other person is the one moving. Let's say I'm watching another person moving in complete. Let's empty the universe. So it's only me and another person, and he's flying past me in his spacesuit. Right? I'm only out there in my spacesuit. My friend is out there in his spacesuit, and he's zooming past me. So, well, I claim he's moving because I feel stationary. He feels stationary, so he thinks I'm moving, right? We can each claim whatever we want because we don't feel, we are both inertial. But according to Einstein's relativity, mm, I'm watching his clock ticking slower and he's watching my clock ticking slower. That's according to Einstein. What about according to the ether theory? So I think according to the ether theory, first of all, Einstein's relativity works because in ether theory, I cannot tell that I'm moving unless I use, like an advanced interferometer, like my interferometer with very very small, like pico meter wavelengths, like gamma ray. Like if I have a handheld three plane interferometer, right, we could build a small one that rotates and discovers interference. So we can have a handheld three-dimensional interferometer basically inside our phone, maybe. So I can tell if I'm moving relative to the ether, but that's advanced. Without that, I would need some huge rig. If I'm using a laser beam, I would need a huge rig, like either a kilometer or two or three long arm or thousands of mirrors to get the same effect of kilometers long arms. Anyway, either way, it's a very complex solution. So let's assume I don't have access to the knowledge of the ether. Okay, so I should still, right? The ether theory just explains reality. So according to reality, we cannot tell if most of the time, without this advanced interferometer, we cannot tell if we're moving or not relative to the ether. So we basically need to come up with the ether theory needs to be able to explain that in normal life we cannot know if we're moving or not, meaning Einstein's special relativity and right is correct for all intents and purposes. Most of the time Einstein's relativity is a good estimate. This is so funny because Einstein said, I'm going to give a correction to Newton. And now here I come and I'm saying I'm going to give a correction to Einstein. Most of the time, without advanced equipment, most of the time, yeah, Einstein's relativity is correct. You can just assuming you don't know where the actual ether is moving, you don't need to know. You can still make accurate predictions using Einstein's, and it's actually not even Einstein. It's Einstein's. They call it Einstein's relativity, but I think Lorentz gave us the equation, so you can use Lorentz equations. But let's think about the logic. So the logic is that right, Einstein basically said my own clock is ticking slower and that modifies how I observe reality. So if I'm looking at the other guy and he's moving fast, well, in my mind, well, his internal clocks are moving slower, are ticking slow. His clocks are ticking slower because he's moving relative to me. Einstein, of course, is an unscientific theory because it's magical thinking. It doesn't make any sense. There's no logic. Well, there's no logic behind the constancy of the speed of light. Why is the speed of light a constant? That doesn't make any sense, right? He didn't give a reason in his 1905 paper. He didn't say, let's assume a reason, let's assume a mechanical reason for the constancy of the speed of light. He'd never said that. Um, right. Well, I was going to say something really wise, but too many things at once. Anyway, okay, that was coffee. Okay, let's get back to my point is that I believe that with or without, right? Einstein just assumes a constant speed of light. And based on that, he develops his theories of special relativity just because of the assumption of constant speed of light. And, basically that's enough. His other assumption is incorrect that all the laws of physics, that's not true because I believe I can build an interferometer that will detect, but it doesn't matter. He just assumes a constant speed of light without giving a reason, a mechanical reason. He gives a magical reason. Let's assume based on nothing. That's not science. In my science, you need to give a mechanical reason. So in my science, there's obviously right. I start actually from understanding gravity. If you try to understand gravity, you come up with this flow of a liquid, and this liquid blocks particles from moving, so there cannot be particles, so everything must be waving through this liquid. Quantum field theory. Therefore, light must be a wave. I don't need Young's experiment. It's good to confirm everything, but I'm compelled to turn everything into a wave. And so light is a wave, and therefore light travels at the speed, right? As a wave, waves always travel at the speed that the medium is waving at. Every medium, each medium has its waving speed, the speed at which its wave travel in it. Air has its sound wave speed. Water has its sound wave speed. Water has its surface wave speed. There's different types of speeds. I've seen people create shock, weird waves in air and in water that travel very slow. It's possible to create different weird waves. So, like you, anyway, it is possible to create really weird waves that travel at different speeds. But the medium, like certain, like light, the type of wave light is, as Maxwell explained, which is an interaction of electric and magnetic, right? The electromagnetic field, what that is, right? So so the light is a special type of the waving of this liquid of that creates gravity. Well, that is the ether, right? Now everything fits together, perfect. So I'm giving a mechanical, like a complete story, a complete mechanical story to the universe. I look at the apple fall from the tree, and I think, what could cause this? This always nagged my brain. This was always a nagging thought. What is going on? Why, at the end of the day, why is the apple suddenly accelerating towards the ground? What is going on here? So I think is that where I started from? No, I don't think so. I first looked at Newton's. I just took. I think I don't remember. We need to look at the videos because I think I started from Newton's. I was trying to understand general relativity. I was trying to explain it. At that point, I don't think I understood. I had my own like ether theory. I think what happened is, I think it started from black holes. Yeah, I was watching Veritasium. I just reviewed all the videos. I was looking into, just watching all the videos. I mean, looking at just the names of the videos. I was just curious. And then you see that I was talking about all different sorts of things. And then one day I reviewed Veritasium. Something strange happens when you follow Einstein's mathematics. So I was watching that. Well, not watching. So I think that's where it all began. I remember basically I was thinking about his video, watching his video, and then reviewing his video and reviewing his video. I think multiple times I broke it into pieces. I still didn't have a coherent theory of my own. Then I and then I tried to, because I remembered when I first heard about the Schwarzschild radius. I was thinking, you don't need Schwarzschild to predict a black hole. I remember when like I remember somebody talking about it, or I immediately it came up when I in high school or something, that when you look at the equation, like GMM over R squared, the closer you get to R equals zero, obviously this thing shoots to infinity. Obviously, this is going to give you something really weird. You don't need Schwarzschild for this. Something weird happens when you follow Einstein's math. No, no, it comes directly out of Newton, which comes out of Kepler, which comes out of Tycho Brahe's watching the planets. So it's something weird happened when you watch the planets. If you watch the planets, then it's something weird. If you just follow the logic from watching the planets, something weird happens, and you can see like the infinity, the singularity comes at you whether you like it or not, from right from there, the black hole singularity. Anyway, so I don't remember exactly what happened, but I sat down with a piece of paper and I said, okay, I gotta think this out. What's going on? And I still have that piece of paper, and I actually uploaded it. So I did. Okay, F equals ma, and F equals GMM over R squared. So MA equals GMM over R squared. All right. The M's drop out, and you have A equals GM over R squared. But A is a vector, and R is a vector. This is a vector field equation of curvature. Immediately you get the curvature of space. Space is curved, meaning you can drop a test particle of any mass, right? We're assuming M does not equal zero, otherwise we would not be able to divide both sides. I'm not sure if you're not allowed to divide both sides if it's by the same thing. I mean, it doesn't matter whether it's zero or not. I mean, it's not, you're not allowed to divide. Anyway, you can get as close as you want to zero with the mass particle, with the test mass particle. And you can spread those in your mind, right? This is now a thought experiment. You can spread those test particles anywhere you want in the universe. And you have Earth at the center, or a point mass at the center of the universe. And you can see each, right? You have a vector field, right? You have a gravitational acceleration vector field equation based on just Newton's, like just observing basically from Tycho Brahe's data. So then you see that every test particle you place anywhere in the universe starts moving slowly in the beginning towards Earth, towards the center mass. Then it accelerates. It's always accelerating, and the acceleration keeps growing. It's not a linear acceleration. It's the inverse square law acceleration. The acceleration is the inverse square law. Fine. And I was thinking, okay, it's going to reach some speed when it impacts this test particle. At the end, is going to impact on the surface of the Earth. And I was thinking, okay, let's assume the Earth is a black hole. So let's assume that at the Schwarzschild radius, you don't need to call it Schwarzschild. You can call it Schwarzschild because he came up with this radius, but you don't need Einstein's general relativity field equations to predict this. You don't need that. You can go back to Tycho Brahe and get it from him, from Kepler, from Newton. And so you assume, let's assume a black hole. Let's assume that at the surface of the Earth, this test particle reaches the speed of light, 300 million meters per second. Okay, so converted I converted Newton's field equation from a vector acceleration vector field equation. I integrated into a velocity vector field equation, a gravitational velocity of this test particle, and then I had it. I had the velocity, and then I just set the velocity to the speed of light, and I integrated from infinity. I put the test particle at infinity, and I integrated from infinity to this radius, assuming at the radius the test particle has reached the speed of light, and I got the Schwarzschild radius. And it makes perfect sense, but this means that space is flowing. I mean, that is obviously space is flowing, but this explains gravity so well. Oh, obviously, it's a liquid. It's some sort of a liquid. Anyway, and at that point, I was bewildered. I said, "How could this liquid be all around us? This can't be true because we're in this liquid. We should be suffocating in this liquid, and we should be basically immobile because this liquid is all through us, and it's pulling the moon. It's pulling galaxies and clusters of galaxies. It's holding the universe together. This has to be such a rigid fluid. Particles cannot move through it. It doesn't. It was strangling the motion of any particle, and I was so bewildered. And I went to sleep with this bewildering thought that there's a contradiction. How can I make this gravitational theory make any sense? It doesn't make any sense. Anyway, I went to sleep, woke up in the morning, and I was having a conversation with someone. I told them, this is so bewildering. We seem to be surrounded by this fluid that's strangling any motion of any particle. It's like the only way you can move through this is as a wave. And then I said to myself, Jesus Christ, obviously everything is a wave. There cannot be any moving particles. In this universe, there are no moving particles. This liquid is not going to allow, it's blocking the motion of particles. So everything must be a wave. Oh, so that explains, the particle wave duality. That's why everything behaves when it moves, when you're not looking, as they say. It behaves, meaning when you're not interacting with the wave, when you're not interacting with the particle. But it's a wave the whole time. It's a wave. It's only in an instant when you interact with it, for some reason, it looks like a particle. I don't even know what that means. I don't know what that means. Okay, whatever. Yeah, fine. When you interact with it, it looks like a particle. Fine. But when you don't interact with it, when it's in motion, it's a wave. Perfect. That's perfect. And that's how everything got started. And then if it's a wave, then light must be a wave. Well, obviously light is a wave. So that's the ether. And I said, oh, then that's the ether. Then I started researching and I see, oh, Einstein said this already. Similar. He didn't say it's moving. He didn't understand the flow of space. Okay, I mean, Einstein. Okay, I don't care, but he said it. It's not like I'm the first guy in the universe to say this, that the ether is gravity. Einstein said it in 1920 in Leiden in his speech. So obviously that is, it's obvious. There is no resolution to this. Okay, one second. Let me get a message. Stereochemistry. Sure, I'm here. All right, so Oh, two people are watching. That is incredible. Let me give you the link to my Discord because I'm always happy to have people join me and ask questions. You see, I'm different than the scientific the scientific industrial complex. They don't just give you a Discord. Maybe later when I'll be very busy with many people, I'm not going to entertain. But right now, anyone is welcome to ask as many questions as you want. But please, only in Discord. I cannot read questions. It's one or two questions is fine, but it puts my brain to sleep when I have to read so many comments from the same person. So if you want to come and join me in my Discord, that would be nice. You can also join me if you want here on StreamYard, but I prefer Discord. Discord is like a more integrated environment. Okay, so the topic of the day is special relativity. Let's resolve the two observers paradox using ether theory. What I want to show is that there is no difference. Like, I don't care. Einstein did, you could say, a good job explaining. By the way, I wrote. No, I'm not going to go there. Anyway, so Einstein did a good job, you could say, with or Einstein or everybody use in special relativity. Everyone explained all the apparent paradoxes. So, but these paradoxes are also explained with ether because you don't need to assume that you know where the ether is, obviously, for the paradoxes to be resolved, because there are no paradoxes in reality. You cannot have a paradox in reality. So these paradoxes are resolved. So, but what I want to show is any paradox you show me, I want to be able to resolve it. I want to make sure that I can resolve it using the ether theory, that it fits the ether theory with no issues, no issue left behind. So let's take a video that talks about a paradox. Yeah, let's share this tab. Let me see anything interesting. There's nothing interesting here. No. So peering into the secret life of electrons with Ali Yazani. Okay. Dynamic gravity. Who is this guy? I am the omega male in the tribe. Either am the beginning. Anyway, how Roman numerals could have been invented. Gravitational index of the heterotic string. La 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 la. All right. Okay. Let's find a video that discusses a special relativity paradoxes. So I claim any paradox you resolve without ether, I can resolve with the ether. There's no ether does not impact a paradox.
Now they're moving, and in our universe, moving objects undergo length contraction and get shorter in the direction. Suppose there are two rockets attached by a very long, thin string. If both rockets suddenly accelerate the same amount at the same time, they should stay the same distance apart. Except now they're moving, and in our universe, moving objects undergo length contraction and get shorter in the direction of motion.
Let's show
motion. The rockets and string should each have their lengths contracted and be shorter. So do the rockets and string as a whole contract?
What do you mean Bell's spaceship paradox? So Bell came up with this specific paradox, I assume?
With the two rockets closer to each other? Or do the rockets individually contract but stay separated the same amount, while the string shortens and risks snapping? Assuming the string has no significant.
So as far as I understand, even according to Einstein's special relativity, it's an optical illusion. But because the universe is optical, it has optical ramifications, meaning, for example, if this has an electric charge, the electric charge is greater, right? let's say you're here in the center of the string, there's more charge condensed right next to you, and you get all of Einstein's explanations of electromagnetism. You get them. I was thinking maybe a length contraction is nonsense, but I don't think so. I think length contraction, it's confusing. It's an optical illusion, but the universe is optical because everything is a light wave.
Significant strength, the spacecraft shouldn't move any differently than if there were no string at all. And since they both underwent the same acceleration, they should stay separated the same as when they started. Which means when the string shortens, it must snap. But how? Is length contraction a real physical force?
Wait, I missed something.
Shortens, or do the rockets and string as a whole contract, with the two rockets closer to each other, shorter in the direction of motion? The rockets and string should each have their lengths contracted, and
Wait, so length contraction is L times gamma? So it's contraction. Usually the time is divided by, but the length is multiplied by. And I still need to see the derivation. I know the derivation of gamma for T. I didn't look at the derivation for L. So I need to make sure they didn't mess that up.
be shorter.
And yeah, I'm not afraid to say that. So as far as I'm concerned, I need to make sure no one messed up any calculation. I cannot just believe someone didn't mess something up. I cannot just believe their math is good even though I don't understand it. If I'm old enough at this point to say if I don't understand something, then it's nonsense. And as long as I don't understand it, it's nonsense. And that's it. I have to be brave and stand against everyone and not submit to any so-called experts or mathematicians or logicians. I don't care. If I cannot understand what you're saying, then for now I'm going to ignore it and say it's nonsense as far as I understand. It doesn't make any sense to me for now, Maybe tomorrow it will make sense. So for now I have to halt the debate. I don't understand. Like I don't understand 1 + 1 = 3. 1 + 1 = 3. I just don't understand it. So as long as I don't understand it, I have to halt the debate and end it with it's nonsense. 1 + 1 = 3 is nonsense. So as long as I don't understand length contraction, it's nonsense. I cannot trust their math. But I haven't done the calculation. So for now, it's okay. I'll go with there. I mean, does it make sense that it contracts and not actually stretches? I didn't even look into that. I don't know. I honestly don't know how they derive it. I need to look into it. All right, let's continue. So Bell's spaceship paradox. Move back a little bit. Start.
Of motion. The rockets and string should each have their lengths contracted and be short.
I mean, my intuition is I don't know why he has the engines on and why he's talking about acceleration when he's discussing special relativity. In special relativity, we only discuss inertial frames. We're not discussing any accelerating frames, as far as I know, frames of reference. So we're not supposed to discuss acceleration. The engines should be off. So I think his engines are off. It's just that he wants to say they're zooming by. Now, if they're zooming by and they have a string connected, then it's one thing. Then why? What is even the question? I don't understand. It's one object.
Shorter. So
This has nothing to do with ether. This is, the basic logic.
do the rockets and string as a whole contract, with the two rockets
Yes, the whole thing contracts.
closer to each other? Or
I don't know why he's showing a ruler. I mean, that's confusing. Unless you're saying the ruler is stationary, maybe put it like on Earth and the rockets are zooming by, but the engines should be off. There's a rocket here.
do the rockets individually as a whole contract, with the two rockets closer to each other? Or do the rockets individually contract but stay separated the same amount? While
Why would you say that? That doesn't make any sense. I don't understand why you would say they stay separated the same amount. Why?
the string shortens and risks snapping.
What? That doesn't make any sense.
Assuming the string has no significant strength, the spacecraft
Right. If you just assume it's particles, right? Let's assume it's just particles. But I would say just basic logic. You're just assuming. Why would you assume this spaceship contracts and this string doesn't? For the same reason, this is symmetric logic. For the same reason, this spaceship contracts, this spaceship contracts, right? You're going to admit that the same logic applies. Why don't you say that about halfway through that, right, everything about this block contracts? Why would you say that? I don't understand. The whole point is that the location changes, right? Why does this ship contract? Why do we have less contraction? Because by the right, we're looking at this at the front of the ship and at the back of the ship, and we're saying that the signal takes time for it to reach me. So by the time this reaches me and this reaches me, well, the back has already moved forward, something like that, and it contracted. It appears like it contracted, and for all intents and purposes, it contracted. Now, the people on the ship, of course, don't feel any difference, and nothing physical has happened in the universe. This is just it's an optical illusion with all the optical implications. I wouldn't say it's an optical illusion. It's an optical artifact. It's an optical effect. This has to do with optics. The optics. It's not an illusion. It's just an optical reality. If I have a laser beam shoot at me, a high power energy beam shoot at me and kill me, that's optical effect. It's not an optical illusion. So some things are optical effects and some are optical illusions. This is an optical effect. There is effect to this optical effect. There's there's artifacts. There's things that come with this optical effect. It's an optical effect.
shouldn't move any differently than if there were no string at all. And since they both underwent the same acceleration, they should stay separated the same as when.
No, no. Oh, he's saying they should each be. That's like a. Okay, now I understand the paradox. He's saying they should be wherever they were. They should still be. Why should this one move forward and this one move backwards? Yeah. Okay.
when they started, which means when the string shortens, it must snap. But how? Is length contraction a real physical force?
Gravity, electromagnetism, length contraction. It's like a real force.
Yes, it is.
Oh.
From a certain point of view.
Good.
The electromagnetic forces which hold the string together undergo length contractions too.
Well, from my point of view, not not you couldn't say it's real. It's from my point of view. It's from I'm being impacted optically by this transformation, but it's not really happening to it can't be happening because two observers, one is moving alongside with this electron proton pair and one is moving relative to it, are going to observe different things. So you can't say that this really happened to the field. You have to say, right, you can't have two different things, contradictory things happening to the field. The field, this line is either here or it's somewhere else. So this transformation must be an optical effect that is different to different observers. But this is just optics. This is not the real field. The real field, I would say, is relative to the ether. Einstein would say never changes. But never changes means with respect to Einstein would say never changes with he would never say that. He would always say with respect to. That's the theory of relativity. So he would say relative to the, let's say, the person moving or relative to these electrons, nothing changed. And I would say, well, of course, relative to them, nothing changed. But Einstein agrees their brains change. Anyway, the point is, relative to an ether, something happened. But, it's relative to the ether. It's just another legitimate frame of reference. There's nothing right? That's the beauty of the ether theory. There's nothing special about it. It's the mechanical explanation, whereas Einstein doesn't have a mechanical explanation. Einstein basically has an implicit ether. That's what I wanted to say at the beginning. Einstein has an implicit ether by saying the speed of light is a constant for all observers, all initial observers. That comes out of assuming an ether, a liquid ether. So he skips that step. I don't Otherwise it makes no this assumption makes no sense. The assumption must be light is a wave, everything is a wave in this medium called an ether, and therefore light has a constant speed in reference to all observers. When in reference to all observers, that's actually that that I don't know if anyone thought of that. So Einstein didn't explain that a moving clock ticks slower, so it views the world differently, so that it views light moving at a constant speed. So a moving clock slows down, it's always seeing the waves moving away from it at the same speed. That's the nice thing about it. So like if I move in a boat, the waves moving away from me slow down the faster I go. But that's a boat. There are no boats in ether. There are no particles in ether. Everything is a clock in the ether. Everything is a waving clock. Everything is a photon clock in ether. So when I move, my internal clock slows down more and more and more so that I always see a constant speed of light. That is the mechanical explanation to Einstein's assumption postulate that the speed of light is a constant for all inertial observers. Now if you make this correction to Einstein, now it's a scientific theory. Now it's a mechanical theory. Now it's fine. It's no longer unscientific. It's no longer magical. And it still works. There's no difference. Everything Einstein assumed, now all that's left to prove is that the speed of light, the speed of the wave, has nothing to do with light. The speed of the wave appears constant to the ticking moving clock. It's always going to measure the same speed of wave. That, I don't know if Einstein ever proved it, but that you need to prove. So as long as and that's why, so you need to prove Einstein's postulate. Now we can prove, if we can prove Einstein's postulate, then that's basically ether. That's the missing link. Let me get a message on Discord. La 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 la. So he's getting kicked off our server. Weird. There is no one here but me. And I am streaming live on YouTube. So I'm not doing that. Maybe you have a connection issue. Maybe it's probably with Discord. Yeah. I never heard of anyone with such an issue. Anyway, okay, okay. Is he watching, listening? I don't see him here. He is Carlos. The old channel has loads of videos and some mistakes. He seems to be close to me, but very different. I start from gravity and I get to quantum field theory directly from there. He ends there, yes. No, I start from there. He denies quantum effects. I don't. I predict them. LOL. Okay, I'm streaming, so you can type here, but explaining an important thing. See you. Okay, so okay, go on. Good. All right, let's continue. Oh, you're listening. That's good. Anyway, so let's get back to our video. This is brilliant. This realization is brilliant. This is really, really important. So Einstein came up with the speed of light is constant for all observers. I don't think he ever proved it, but of course he doesn't prove it. I can prove it, assuming the ether, and he can't. I don't think he can. Can he prove? I mean, if he proved it, it wouldn't be a postulate. It wouldn't be a postulate if he proved it. But if I can prove it, then I'm correcting. I'm giving one more layer. I'm giving a foundation to Einstein. Without me, Einstein doesn't have a foundation. Special relativity is unbased. It's unsupported. It's missing a layer of support. It starts with a postulate. And we know from who? From Maxwell. No. How do we know the speed of light? We know from Michelson and Morley. We don't. We don't know this from Michelson and Morley. Einstein never heard of Michelson and Morley. He said that in 1950. He didn't hear of Michelson and Morley by 1905 that he wrote his seminal special theory of relativity. He said, otherwise I would have mentioned it, which makes perfect sense. I mean, so I don't know. I think in his mind, he had the intuition of an ether because he spoke about it in 1920 that the ether exists. So I think he had this ether in mind, but it doesn't matter. He missed the foundation. He just started from a postulate: the speed of light is constant for all inertial observers, for all observers in inertial frames. Okay, I can prove it. Let's prove it. Hopefully I can prove it. If I can't, then I can't. But hopefully we can prove it. If we can prove it, this is so foundational. We no longer need Einstein's postulate. We have, right? If the ether gives us this postulate, then it's no longer a postulate. The ether is now the postulate, and the ether is the theory. Instead of the theory, right, you could say Einstein presented a theory: the speed of light is constant for all observers, for all inertial observers, or observers from inertial frames of reference. Okay, that's a nice theory. That's a magical theory. There's no logic. There's no reason behind this theory. We cannot imagine why this theory would be true. Why? I don't know. It's like he pulled it out of thin air. But if you assume the ether, and you assume every clock is an ether wave clock, namely light, not a photon clock. The photon is the wave when you interact with it, but otherwise it's a wave. So it's a right. This is going back to dialect. So dialect, they missed that step. They should have said, let's prove that the speed of the wave as observed by any inertial frame of reference is always a constant. Let's prove that. That they never did. That's so funny that they never did it. So we're gonna assume, right? So let's go through this. This is amazing. I don't think anyone has anyone ever done this. Let me look this up. Let's look it up on YouTube. One second. Let me open a new YouTube. This is such a beautiful rabbit hole. It's so beautiful. This chick, Jesus. I love these bulky chicks. Jesus. These pretty faces with bulky bodies, they're the best. I love bulky chicks. Big bulky chicks are the best. Anyway, so back to reality. So this is such a beautiful it's such a beautiful rabbit hole because the deeper you go, things fit together so beautifully, and the missing pieces fit together so beautifully. It's so much fun. This is like the most fun you could ever have. So funny. So funny and so much fun. Okay, I'm a little bit hungry, but this is too exciting. Let me see. Let me see. We have three people. There is Carlos. So Carlos is saying using wave mechanics, it has to be constant in relation to the medium. Yes, that we know as what's known as the preferred frame of reference. If the medium is the if you observe from the medium's perspective, then of course the wave speed is a constant. That's fine. Yes, but the question is, assuming a medium like water, like water waves, sound waves, assuming a medium, we know, right, we from simple observation and logic and waves, the speed of waves in any medium is a constant. Okay, that's a given. We start from that. That's logical. But now let's take a moving clock. It's always moving clocks. Don't think about a moving object because that's going to throw you off. There are no moving objects in this universe. Everything is a moving clock because everything is waving in this universe because quantum field theory is correct because of the ether. Carlos, more comments. Even in other, but if you're going to start writing comments, it's going to be very difficult for me to. I'm going to fall asleep. I noticed that I fall asleep when I read too many comments. Even in other frames of reference, what changes is the frequency. Uh, we'll, we'll see. We'll see. We'll see. If they are moving, the waves cover more distance. We'll see. We'll see. We'll see. And thus take more time. We'll see. We'll see. Let me think about it slowly. You're too fast, and it's gonna put my brain to sleep. You're gonna overload my brain, and it's gonna fall asleep. Wait, I wasn't showing. Oh, I was showing your comments. Okay. So it's the Doppler effect. Yeah, yeah. The Doppler effect seems to be involved in this discussion. We can talk later. Yeah, yeah. Let's talk later. When you're available to talk, let's talk because reading comments is way too difficult for my brain. Like if I talk to someone, it wakes me up, but if I read comments, I fall asleep. That's just my brain. Oh my god. Anyway, what I wanted to discover, here we are on the YouTube. What I wanted to look at is, has anyone proved Einstein's postulate? How difficult can it be? So, prove it's not even Einstein, it's constant light. It's not even constant light speed, it's constant speed of a wave from any moving. Oh, okay, it's too complicated. If I have to go and say these sentences, it's going to put me to sleep. Okay, prove constant light speed. Let's just see if anyone proved. Okay, so this guy, base For special relativity theory, why is the speed of light constant? All right.
Mechanics. If you're looking at a huge mass, the physics that comes to play then is called general relativity theory. If you're looking how the universe behaves at extreme speed, then it's special relativity theory. So speed is the fundamental core of special relativity theory. But what is speed? In everyday life, speed is nothing but distance divided by time. For example, if a car reaches a 100-kilometer distance in 1 hour, we can say that the car speed is 100 kilometers per hour. It looks simple, but speed has unusual features when it gets into very high numbers, especially its unusual effect on space and time. Speed is relative. It can vary one to another. This means that different frames of reference will get different speeds of the same moving object. But the speed of light is not like that. It travels at a constant speed, which means that the speed of light is the same for all observers, no matter the observer in motion. But why is the speed of light constant? Why is it always 300,000 kilometers per second? How did scientists figure out the speed of light? What is the great discovery Einstein uncovered with the help of knowing the exceptional feature of light? Why can't anything travel faster than light? Let's see.
Okay, let me go into this video.
As a matter of effect, the study of light doesn't just arise during Maxwell and Einstein's time. The debate has been going on for about 2,300 years. As far back as the times of ancient Greece, the philosopher Aristotle said that light has no speed, that light was instantaneous. This claim lasted for more than 1,500 years because measuring the speed of light is not trivial. Finding the speed of light is not as easy as finding the distance a man walks. Light travels so fast that there was no way to detect its speed at the time. In the 1600s, the famous scientist Galileo believed that light had a definite speed. He not only believed, but also tried to measure that speed. He and his assistant each took a shuttered lantern, and they stood on hilltops 1 mile apart. Galileo flashed his lantern, and the assistant was supposed to open his lantern shutter as soon as he saw Galileo's light. He tried to calculate how long it would take the light from his lantern to reach the assistant on another hilltop, but he could not. The reason is that a mile is too short a distance to calculate the speed of light. In fact, knowing the speed of light now for light to reach 1 mile away would take 0.000005 seconds, far too fast for human reflexes. Then in 1670, the Danish astronomer Ole Romer was studying the orbital path of Jupiter's moon, Io. After studying its motion for 2 years, he found something strange. Io takes 1.77 days to orbit once around Jupiter. The time it takes to make each orbit.
Okay, he's going the wrong direction. You need to start from water waves or air sound waves. The fact that he's going to empirics, I think he's in the wrong direction, but I'll give him a chance.
Is always the same. But he discovered that the moon didn't always appear where it was supposed to be. At certain times of the year, it seemed to be slightly behind schedule. At other times, it was slightly ahead. Romer wondered why it would orbit more quickly sometimes and more slower at other times. Finally, he noticed that Io seemed to be ahead of its predicted orbit when the Earth was closer to Jupiter, and behind when it was further away. Perhaps if the speed of light were infinite, then Io would be visible to us on Earth at the same time its orbit. However, he found that the light from Io takes a few minutes to reach Earth, so light has a certain speed. He also found the speed of light using the locations of Earth and Jupiter, so he calculated the speed to be around 200,000 kilometers per second. Following this, in 1728, James Bradley, an English astronomer, found that Jupiter's distance was not far enough to calculate the speed of light, so he spent time observing a distant star. Observing the star, he found that its apparent position changed throughout the year. He calculated the speed of light to be 301,000 kilometers per second by investigating it through a stellar apparent method. It wasn't exactly the speed of light, but it was close. Although subsequent experiments were carried out by other scientists, an experiment in 1887 became the most.
Okay, this is just how they discovered the speed of light. This is not the speed of light is constant for all observers in inertial frames of reference.
Famous. Sound needs a medium to travel through, such as air. Ocean waves are relative to the water. Similarly, Michelson and Marley conducted an experiment to prove that light needs.
Wait, he just mentioned water. Why did he do that?
It wasn't exactly the speed of light, but it was close. Although subsequent experiments were carried out by other scientists, an experiment in 1887 became the most famous. Sound needs a medium to travel.
1887? That's a year after Michelson. And he's showing Michelson's experiment. But that's not 1887. That's 1886.
The year. He calculated the speed of light to be 301,000 kilometers per second by investigating it through a stellar apparent method. It wasn't exactly the speed of light, but it was close. Although subsequent experiments were carried out by other scientists, an experiment in 1887 became the most famous.
Which one? What happened in 1887? Which he's showing Michelson and Morley from 1886. Wasn't Michelson? He published in 1886. That's what I remember. No, Michelson and Morley year. Maybe I'm wrong. Oh, 1887. Okay. Okay, so why did I remember 1886? I don't know. Okay. Let's continue.
Sound needs a medium to travel through, such as air. Ocean waves are relative to the water. Similarly, Michelson and Marley conducted an experiment to prove that light needs a medium to travel. The experiment was conducted to prove.
Right, good. But I wonder if he's going to take the ether direction the ether as a water direction or not?
That a substance called aether pervades the universe and acts as a medium for light. This experiment ended in failure, and it became clear that light does not need any medium to travel. It can travel through both medium and vacuum. The Nobel Prize was awarded for this discovery. At the end of their failed experiment, they calculated light speed to be 200.
Wait, he got a Nobel for this discovery? What? Wait, what? Michelson and Morley, Nobel, and then were awarded in 1907 Nobel Prize in Physics for their pioneering work on the measurement of the speed of light and the development of interferometry. Specifically, their Michelson-Morley experiment 1887 aimed to detect a hypothetical ether wind predicted. There's no ether wind. There's just ether gravity predicted by classical mechanics. Classical mechanics. Yeah, there's classical mechanics and there is quantum mechanics. Quantum mechanics should still be classical mechanics. Everything should be classical mechanics, which would have revealed anything but classical mechanics is non scientific, which would have revealed the motion of the Earth through a hypothetical luminiferous ether. Right. So, what did they get the Nobel for? I mean, can you get Nobel for contributions to interferometry? That doesn't make any sense. Michelson only designed and built their experiment conducted despite meticulous efforts. They failed to detect any evidence. Yeah, but that's like 1,000 years ago. They didn't do the calculations. I mean, what did they predict? What speed of ether did they predict? This doesn't make any sense. Show me. I need to see their prediction before they conducted the calculation. You can't just run an experiment nilly willy. That's not science. That's I don't know what that is. The Michelson Morley experiment laid the groundwork for Einstein. No, it did not. It did not. Einstein said he never heard of it. And it doesn't look like he heard of it before his paper. So it's nothing to do with his work, development of special relativity, which he didn't know that they proved there is no ether when he came up with his theory. I think he had in mind ether. Let me see. Did Einstein in his paper did he say there is no ether? Wait, are we here? Yeah, okay. Let me see. So Einstein spelled Einstein but pronounced Einstein. Einstein, ether. Einstein ether. I want to see what did Einstein say. So Einstein ether theory is a modified theory of gravity that incorporates a dynamical unit. This is my theory. So someone already wait, what? What's going on? Unit time like vector field? What? Unit time like what? Often referred to as the ether to break local Lorentz. What is local Lorentz symmetry? What is going on here? This theory is an extension of general relativity, aiming to address certain issues and provide an alternative to dark energy models. Okay, I resolve, like everybody else, I resolve dark energy. I mean, I don't say anything new except for very, very few things. But one of them is I, of course, address dark energy like everybody else. The ether field is a unit time-like vector field that arises naturally from the theory. Breaking local Lorentz symmetry. No, not my theory. The theory has been applied to various areas, including waves, stars, black holes, and cosmology. Constraints from theoretical and observational perspectives have been discussed. Recent development in 2019, researchers explored vacuum solutions in the Einstein ether theory, highlighting the theory's potential to explain certain phenomena. In 24, a summary of the Einstein ether theory was published, including scalar field modification, Brans-Dicke theory, and I don't know what that is. Horn-Deskey's theory. Historical. The concept of the ether was initially rejected by Einstein. Really? Who demonstrated its non-existence through the Michelson-Morley experiment. He'd never heard of it. That's not true. However, Einstein later revised the idea of an ether in his 1924 paper concerning the ether, describing it as a relativistic concept influenced by matter and influencing the structure of space. I don't know what that means. Current status. The Einstein ether theory remains an active area of research, exploring its, well, so I'm doing active research, exploring its potential to unify physics and address open questions, modern cosmology, such as dark matter, dark energy. Yeah. The provided information focuses on the Einstein ether theory as described in the search results without referencing whatever. Interesting. Einstein killed the ether. Now the idea is back to save relativity. The luminiferous ether has become a byword for failed ideas. Now it is being revived to explain dark matter, dark energy, and potential unified physics. Okay, that's basically me. So, but that's in newscientist.com. Okay, we'll take a look at that. Archive. Abstract. We review the status of Einstein ether theory, a generally covariant theory of gravity. But I heard what Einstein said in 1920 about ether and gravity, but he said it's not moving, so his theory is wrong. It's still no good. It's getting there, obviously. A generally covariant theory of gravity coupled to a dynamical unit time-like vector field that breaks local Lorentz. Yeah, I don't know what these words are. Aspects of waves, stars, black. Anyway. La 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 la. Einstein ether theory. And Einstein, let's look it up. An Einstein ether theory is an alternative theory of gravity that adds a vector field to the theory of general relativity. There are also scalar field modifications. La, 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 la. My brain is falling asleep. La 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 la. Let me drink some water to not fall asleep. I need to talk to someone, please. Can someone please? Oh my God, Carlos, you're gonna put my brain to sleep. Can someone come online and talk to me, please? Because I'm falling asleep. It's too difficult. Let me get a drink of the water. 1 second. Yeah, I know you guys need to hear that I'm alive as I'm drinking, so I'm helping you know that I'm alive. Okay, so it says here vacuum solutions. Anyway, no, no, no. Okay, whatever. I don't think anyone has ever come up with my ether theory. Einstein had. I read what he said. It's not it. I mean, it's close, but no cigar. Let's see. Einstein killed the ether. No, he didn't. Now the idea is back. The luminous. Okay, whatever. Unify. Yeah. As far as dead ideas, but relativity has run into difficulty in an astonishing twist of fate. The key to relativity's salvation could lie in the ether. Since, what do you mean? Why do you need? What's the problem? Relativity has run into difficulties of its own. It's failed to explain the behavior of the universe at the smallest scales. I don't know why they say this. To continue reading, subscribe today with our introductory offer. What? What? Are you out of your mind? I'm gonna start paying for nonsense? I get nonsense for free. I don't need to pay for nonsense. La 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 la. Share. Okay, Einstein ether theory. In physics, why is it. How to make it dark? Please become dark. Pages for logged out editors. Tools? How do you make this dark? Please become dark. I can't read when it's not dark. And poor you guys. You guys have to be blinded by this white page. Oh my god. The internet was created like they pretend it's white paper, but it's too bright. What's this? Appearance. Oh, they have appearance. But will it remain dark or is it going to change every time? Well, at least not, now I know that's where you make it dark. Okay. Einstein ether theory. No good, no good, no good. I don't care about Einstein. I know Einstein What? Lorentz symmetry? The existence? I don't care. I'm not going to waste my time. What? No, you don't need any of this. I don't know what this is all about. In particular, it is assumed that the action may be written action. Oh my god, action. You don't need advanced math. You need basic geometry. Leave me alone. Leave me alone. Let's get back to this guy. Sorry, everyone. Let's continue. Okay, so this looks like, yeah, Michelson Morley, 1887. I stand corrected. Let's continue.
299,910 kilometers per second. This value was believed and remained in use for scientific calculations for some years. Then, at a turning point in the history of science, the speed of light was precisely calculated with mathematical equations by Scottish mathematician and scientist Maxwell. He was just thinking differently. Electromagnetic waves always travel at the same.
This is, they're skipping now like 100 years back or something. When was Maxwell? Okay, we need to remember these dates. I need a map. Somebody needs to prepare like a linear map of all the great names and their discoveries throughout history. By the way, look at this. They show the Enterprise visible from like from a planet. I mean, this planet is too. It's like a moon, but like what? They have oxygen here. How? How is there oxygen here? There's no. It's barren. There's no life. This is unscientific. And her hips are not wide enough. She needs wider hips. Come on. And she needs a thigh gap. No, no good without thigh. She needs thicker thighs. And his back is too wide. All right. Anyway, this ship doesn't make any sense. They wanted to create like a saucer because everybody was using saucers in space comics. Okay, so my contention is Maxwell. When did Maxwell equation? When did Maxwell equation? When did Maxwell equation? 1834. Okay, about 30 years before Michelson. Okay, and by the way, his equations were not as beautiful as we know today. He came up with much dirtier equations. His students, as far as I know, derived what we call Maxwell's. I don't think he ever saw Maxwell's equations. They put this on his grave, but I don't think he ever saw this. I think that's his grave. Okay, let's continue. So it's 30 years prior, 1834, right? And let's see this. 1830. Wait. So 1834. Oh, wait. Based on Maxwell, the development of Maxwell's equation. Oh, it's 1873. Maxwell published. Maxwell. Wait. When did he come up with his equations? Published a series of papers. Oh my God, this is too difficult. 1850, 1870. When did he? What's the date of his equations? 1862, Maxwell derived the speed of light. Okay, that's after the equations. In 1862, this is like 1887, so that's like 25 years before Michelson is Maxwell's speed of light. But that's from his equations. So 1850, 1870, James Clerk Maxwell published a series of papers that laid the foundation for his unified theory. So I guess it's over time. So it can't be 1870 because in 1862 he already had the speed of light from his equations. 1865 published Dynamical Theory of the Electromagnetic Field, in which he formulated a theory in strictly mathematical form, derived the electromagnetic wave equation showing that light is an electromagnetic wave. Okay, that's 65. But first he derived the speed. This is weird. The timeline is weird. 1870, Maxwell published a treatise on electricity and magnetism summarizing his work. Okay, that's a summary. Okay, so we don't have a specific date. Maybe he came up with like different dates, different equations. These are the four equations. Later, Oliver Heaviside studied Maxwell's work and employed vector calculus to simplify the 20 equations derived by Maxwell in 1865. There we go. Wait, what? That's Heaviside. So Heaviside created these four equations. Heaviside reduced the equations. That's 1865. When did Maxwell derive his 20 equations? Heaviside reduced the equations to the four recognizable ones we use today. I'm falling asleep. Why am I falling asleep? Who's watching? Well, there's five people watching. That's amazing. That's amazing. Yeah, it's weekend. I guess it's time. Like weekend is like people have time waking up and watching us. That's great. But people, you're welcome to join me and talk. We can talk this over so I don't fall asleep. Oh my god, my brain. Okay, these four equations known as Maxwell. Okay, I just want the year. So by 1865, probably Heaviside wrote it. When did? Okay, we need to actually like I wrote, when did Maxwell equation? When did Maxwell derive, publish his equations? Question mark. When did Maxwell publish his equations? A dynamical, that's 1864. This paper introduced the four modern Maxwell's equations. How? He didn't derive them, which unified electricity, magnetism, and optics. The paper was published in Philosophical Magazine 1865, following Maxwell's lecture at the Royal Institution in April 1846. What is going on? That's 10 years prior. What is going on for the 20 years? 18 years. What is going on here? When did he publish his equations? In summary, Maxwell's equations were first published 1865. 2 years? What? That doesn't make any sense. As part of his paper, A Dynamical Theory, whatever. Okay, we'll go with 1865. I'm falling asleep. I think I'm falling asleep. All right, let's get back. We're watching a video. Maybe this will wake me up. Okay, okay. As we know, this diagram makes no sense because a wave, right? This is in 3D. The wave expands in 3D. It's a sphere. So this is the cross section of a sphere, believe it or not. So as the sphere expands, this is the sphere expanding. This is, well, it's multiple spheres expanding. So here is one sphere. This is the wake behind that sphere. Another, well, let's look at it this way. This is a positive sphere, and this is a negative sphere, right? A wave has compression and depression. Compression, depression. So this is the electric field, meaning a test particle that is placed here has moved over to here. That's what it means. Or is experiencing a force, whatever. I don't know. I didn't review Maxwell enough in depth. Something like there is a force on a test particle, or a test particle moves, or who knows what. Maybe it moves, and as it moves upwards, it creates a magnetic field, which means there's a magnetic field this way, which means what? A test particle. What would an electron? How would an electron react to a changing? Right. This is a changing magnetic field. I'm not going to go into that now. It's not important. I'm just just know that this is real. This is a three-dimensional, multiple three-dimensional expanding spheres of electric changes and magnetic changes in the ether, in the electromagnetic ether. What am I going to do? My brain is falling asleep. 6 people watching. I can't read comments. My brain will fall asleep immediately. I can't keep it up. Let's drink water. Let's drink water. I slept enough. I shouldn't be tired. I drank coffee. I should not be tired. Maybe it's just overwhelming. I don't know. Just the thought that I need to derive, maybe deriving the constant speed of light will wake me up. Hopefully, I don't know. Okay, let's continue listening. I'm gonna talk less. Maybe talking is putting me to sleep. Let's talk less.
same speed, no matter if they are longer or shorter waves. They always travel at a constant speed. With his equations, he found the speed of electromagnetic waves and velocity of light are exactly the same
Maxwell. Okay.
numbers, 300,000 kilometers per second. So he finally concluded that if the speed of
I'm curious. This is the permeability, meaning from the word permit, right? So the permeability of free space. How much is free space permitting electric something, electricity, an electric effect? How much is it permitting electric effects? Meaning if you have a test particle, how will it react? Right? If right the permeability of free space is not infinite, it reacts in some manner. It has a reactivity. This is it's whatever that means. I don't know what it means, but this is what right. It's not infinite. It's not allowing an infinite. It's not like any. Okay, I'm not gonna talk. Okay, okay, it's very little, and it is h over m. What is h? H? It's not c. It's not coulombs. What is h? I don't know. And this is f. I think f has to do with something with magnetism. What is the unit of magnetic field? I forgot. This is the permittivity. Oh, this is permittivity. This is permeability. But I think this. Wait, one of them. One of them is the magnetic, and one of them is the electric. I think this is electric, and this is magnetic. I don't know, whichever. They're very very small numbers. So so it's actually not very permitting. This is per meter. Per meter? Per meter? It's not per meter cubed? Okay, whatever. So this is per meter. So this has to these two have to cancel out in order for this to be meters. This has to end up as meter per second, meaning this is second squared per meter squared. So these have to cancel out to second squared per meter squared, whatever. Okay.
speed of electromagnetic waves and velocity of light are exactly the same numbers, 300,000 kilometers per second. So he finally concluded that if the speed of electromagnetic disturbances is equal to the speed of light, then light itself must be an electromagnetic wave. Now, it's clear that light is an electromagnetic wave which travels at a constant velocity. But what is constant? Imagine a
What do you mean it's clear? Oh, constant to this ether. Yes. Yes. Constant to the ether. Yes. But this is uh, this is empirical. Oh, so this might be Einstein's postulate. So Einstein's just saying, but he didn't say it as a. He didn't say, well, based on Maxwell, the speed of light is a constant. He didn't say it's based on Maxwell. The speed of light is a constant relative to the ether. Assuming the ether is not moving, he didn't say any of that. Um, anyway, so that is a mathematical derivation from the wave equation. So Maxwell derived a wave equation. From the wave equation, he derived the speed of the wave. But that's empirical from experiments having to do with electricity and magnetism. So from those, that's empirical. We can also, if we can also derive the speed of any medium is a constant relative to any clock that works on the principle of waves between two reflectors slash detectors, like basically Einstein's clock, Einstein photon clock. So this has right. So we can. I should right. That should be a simple geometrical problem to solve. So this is not. So then we can prove this has nothing to do because he did it. Right? He derived it. I mean, he basically said it's empirical. Empirical is nice, but he didn't make a prediction. No one made a prediction, right? There's no. That's not so science. That's not the science gold standard. The gold standard is make a prediction, run the experiment, validate the prediction. no one, right? He retrospectively, retro whatever, with hindsight, he said, "Oh, I noticed they're the same speed." Yeah, but you didn't make any prediction. He's not right. It's not as scientific. I want to be able to say this has nothing to do with light. He noticed this about. I don't know what I'm. I feel like something is there's like a missing link in the discussion. Okay, whatever. Let's continue.
car X traveling at the speed of 20 kilometers per hour. A stationary person near the roadside now measures the car's speed, and he measures the value at exactly 20 kilometers per hour. Now a car called Y comes from the opposite direction at the speed of 20 kilometers per hour. A person from car Y measures the speed of car X, and it shows 40 kilometers per hour. Velocity of car X plus velocity of car Y is equal to 40 kilometers per hour. Now take another car called car Z, which is moving away from car X at the speed of 10 kilometers per hour. If you measure the speed of car X from car Z, you will get the speed.
As long as you're measuring cars and stuff, you're missing the picture. You always need. I mean, the advantage of Einstein. I mean, the hats off to Einstein. I have to give credit to Einstein for his thought experiment about his photon clock. He didn't get the photon clock right. We already said he had two issues that he used a photon looking like a ping pong. That is the issue. So if instead he would have used light as a wave, which they knew from a long time ago from Young, so he knew light as a wave. If he used a wave clock, and then he didn't even need to use light, just a wave clock of any waving medium. So all these experiments, all these thought experiments, you always need to go back to Einstein's photon clock, turn it into dialects, sound clocks, and now run the experiment. There's no cars, no particles should be in any experiment because there are no particles in nature. There's only waves, and then everything will be everything will make much more sense. You get immediate constancy of the waves, the speed of the waves, at least relative to the medium. And we still need to prove that relative to any observer, any moving observer in the medium, they should all observe a constant speed of waves. We'll get back to that. Okay, let's continue.
Speed of car X is 10 kilometers per hour, because 20 kilometers per hour minus 10 kilometers per hour is equal to 10 kilometers per hour. How can the speed of the same moving object give different rates of speed for different observers? There's no need to wonder because speed is relative. But if you measure the speed of light, no matter how fast you move away from the light,
I'm not even going to think about what he said. It's irrelevant.
or no matter how fast you move toward the light,
He wants to say that the speed of light, how could that be a constant relative to any observer? If you're moving at half the speed of light and you're firing and you're conducting the light experiment, any experiment of the speed of light, well, it should be impacted by your own speed. How could that be a constant?
always shows the same speed, 300,000 kilometers per second. Let's play an example of you traveling on a bike at the speed of 10% of our speed of light, which is 30,000 kilometers per second. So the speed of light.
He's just asking the question again and again. I'm falling asleep. That's useless. Is he going to discuss the speed? There's the clock. Okay, let's give it a shot.
Einstein developed his special relative theory, which gave us a new way of understanding the nature of time. We already know.
And notice that Einstein used a ping pong like wave between the mirrors instead of a wave. Ping pong like a ping pong clock photon instead of a wave photon.
Only light itself can travel at maximum speed in our universe. Can anything travel faster than the speed of light? To get the answer for this, let's take a look at a relativistic mass equation.
No, no more equations. Either you explain it from first principles or I'm going to sleep. No. Okay, so this is clickbait. Base for special relativity theory. Why is the speed of light a constant? Downvote. No. You got everything. It's clickbait. You didn't get anything wrong. You're just clickbait. There's no foundations. You did not explain the base for special relativity theory. Why is the speed of light? You did not explain it. Where's
the end of the result causes time dilation. Einstein is the only man who discovered.
No. You cannot use the ping pong. That doesn't make any. That's not the base. Incorrect. That's just an assumption. You mean the base is the assumption? Why is the speed of light a constant? You saying the speed of light must be constant in order to derive relativity or something? Are you saying everything backwards? I can also talk backwards. Why did I wake up this morning? Because I drank coffee. No, I drank coffee after I woke up this morning. Yeah, okay. Well, that's the reason. Because I drank coffee this morning. That's why I woke up this morning. That doesn't make any sense to you? Well, it does to me.
Feature of the universe, and he described this in his special relativity theory. Does this mean his theory tells us that time really slows down at
Okay,
extreme
okay, okay, okay. Waste of time. Downvote. Clickbait. Clickbait. You did not explain the title. Terrible person. Let's see any comments. Oh, look at this. I waited the entire video to find out why the speed of light is considered constant, for which you said there's no explanation for that. And then you started relativistic. This is why we need to see the downvotes. This is useless. If the downvote would have been high, I would have known this video is clickbait. You see, I'm tired. Obviously I'm gonna fall asleep if this is how I have to go through YouTube. They took away the downvote. They said she died today, by the way. Rajowski, the ex Google CEO, she died today. So she took away. I think she took away, or the new president took away the downvote button. They said it's not to hurt the creator's feelings. That's a lie, because only the creator sees the downvote. So only the creator's feelings are going to be hurt. So obviously that's not the reason you took away the counter. You took away the counter right after Biden, or just before the election, so that people would not see Biden's downvotes. As far as I'm concerned, that's what happened. And that's why you got all the Trump supporters so upset. And that's why you got the insurrection. I mean, you created the insurrection. You are an insurrectionist, Mr. YouTube, whoever you are. Oh my God. Dude, you seriously need to avoid claiming things you can't explain. Terrible. Totally agreed. Eventually, clickbait. Oh my God. And the bad thing is, my brain completely fell asleep. Thanks for this comment. I saved my time watching a useless video. Terrible people. Just terrible, terrible. I'm going to report this video. This video needs to be reported. Report sexual, violent, hateful, harassment, harmful. This is misinformation. Child abuse, promotes terrorism, spam, either spam or misinformation, legal caption. This applies. Oh my God, I'm falling asleep. This applies to links next. Timestamp. Oh my God. Oh my God. I'm in such pain. Okay, provide additional details. The video claims to present something that it does not. Report. Close, whatever. Okay. More people should report more videos. This is terrible behavior. Who is this? Who is this? It's probably some firm. Can't be a person. No individual would behave this way. Patreon. Traffic lights. Traffic. 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 Is that traffic? No. No. Submit. Oh, they have a Gmail, so it's not a firm. Kolonusk. Where are they from? 2021. India. Yeah, it's clickbait. It's a clickbait channel, probably. They have a narrator. We are the aliens. Yeah, they have a narrator. So it's a firm. It's some firm. It's some disgusting company. They only have 18 videos. Oh my God. Community, quantum physics, superposition, videos. They're just trying to make money, trying to milk the public. What else? There's no information. I don't know what to say. That's it. That's all their videos. Oh, they have also Chinese what? Oh, they have Klunusk Indonesia and Klunusk, I guess, in China. 29 subscribers, 81 subscribers. Okay, it's a clickbait channel. More people should report this channel. Just 18 videos with 70,000. Obviously, that's fake. So most of these subscribers are fake. You can't go that far with 18 videos. No way. I don't believe it. And then they promote this nonsensical. Oh my god. Oh my god. This is putting me to sleep. Oh my god. Okay. 5 people are still watching us. I'm sorry. I'm sorry. I'm sorry that I presented a clickbait channel to you. And it showed up first.
As a matter of fact, the study of light doesn't just arise during Maxwell and Einstein.
Up first. This is the first with
As a matter of
3,000 views. Just horrible. Horrible. Okay, let's go to this guy.
difference. In whichever direction we measured, we
So-
always found the speed of light to be
Okay.
difference. In whichever direction we measured, we always
This guy is basically a fanboy, an Einstein fanboy. I mean, he's a fanboy for all of the big names. He never criticizes any. Oh, I see. I already downvoted this video. What did I write about it? Even multiple comments. Even ones close to the speed of light. Without an observer, there is no definition of speed. So I don't know what you mean. All observers, you're just repeating exactly what Maxwell said. I don't see anything new this point. Your Honor, never met a guy that had so much conversations with Einstein. You are the only person who has ever explained, we need to get this guy. I watched dozens of videos. This is why Einstein said, did not understand this as an undergrad. This is the best as a teacher. As a biology, as a historian, one of the best. I never really truly. What an awesome video. This was incredible. I've sat here for well over an hour. So good. I don't remember. Been looking for. I have never understood. I can't have enough of this guy's accent. I almost cried from finally understanding. Okay. Okay, but I downvoted it, so must be clickbait. Why is speed of light the same in all frames? An intuitive explanation. Okay, let's hear it again.
experiment. The one where Einstein imagined himself moving at the speed of light and switching on his flashlight and
Hold on,
wondering.
from the beginning.
When I first wondered about how Einstein discovered relativity, I came across his famous thought
Somebody kill me, please. Let's go to 1.5. Hopefully, we'll understand the accent. Yeah.
When I first wondered about how Einstein discovered relativity, I came across his famous thought experiment. The one where Einstein imagined himself moving at the speed of light and switching on his flashlight.
Why does he wear a bandana? Is he bald? Is he pretending to not be bald? Is he ashamed? Why is he ashamed? Like, why is he showing his face? His name is Manesh or something. He has a pretty wife. He showed his wife the other day. He's proud of having a pretty wife. So he teaches I think relativity probably undergrad. I don't know. So he might be a PhD or PhD student. 182,000 subscribers. Let me check his channel. Forget it. Let's just continue watching.
And wondering, would he see light to be at rest? And somehow this led him to the theory of relativity. And at first I was like, wow, what a mind-boggling experiment. But then I thought, wait a second.
Again.
Einstein imagined himself moving at the speed of light. When I first wondered about how Einstein discovered relativity, I came across his famous thought experiment. The one where
Oh, somebody's with us. Hello. Share this tab. Okay, what's up?
Nothing much.
Nothing much. Well, let me tell you, there's actually 5 people watching us right now. So I think they're here because of the title, Special Relativity. Let's resolve the two observers paradox using ether theory continued. So I don't wanna lose them. And you wanted to discuss something about chemistry, like
All right. I'll come back.
no, no, just maybe we can make it short. Like, what's the question? Maybe I can quickly resolve it.
Uh,
Mm-hmm. Yeah,
okay, like, are bonds real? How do bonds work between like chemical
that's a good
in
question.
chemicals?
That's a good question. That's a good question. I don't know how an electron attracts a proton. I don't know how two electrons repel each other because electrons are waves, but they are waves with mass. So they interact with Higgs, but they still move. We see them move when we have a spark. So we know that electrons are real because of sparks or lightning. When we see a lightning in the sky, those are electrons. When we in the winter drag our feet and touch the doorknob, we see a tiny spark. We see it, though that it looks identical to a lightning. So okay, so electrons seem to be real. They seem to be behaving like particles because a lightning, that's not the behavior of a wave. A wave doesn't look like lightning, and a wave doesn't look like a spark. So electrons behave like particles. However, we've been told, and I'm just going to believe it for now, that they performed the double slit experiment with electrons, and they got electrons to behave like waves, like particles and waves. So we've actually reviewed these videos on YouTube. They don't show the setup. I don't think they ever showed the setup of the experiment, but they did show the results of the experiment. They showed how they get electron electron dots one at a time, but over time it looks the formation, the dispersion of the electrons hitting the detector, it looks like the wave pattern from the double slit experiment, even from Young's, the original Young double slit experiment that confirmed light is a wave. So electrons seem to behave both as a particle and in a wave. So my explanation is that they are particles when we see them, when we interact with them, meaning when light hits, right? So a spark is electrons invisible. Wait. Anyway, a spark. If we can see a spark, that means that the electrons are interacting with light. So because they're interacting with light instantaneously, they show up as particles. However, when they don't interact with anything, they are moving. That's my theory. That's my quantum field theory. My ether theory is that particles cannot move. Particles is what we see just at the instant of interaction. That's what we perceive. But when they move, they are waves. So electrons seem to be waves. They interact with the Higgs mechanism, so that gives them mass and that lowers their apparent speed. They seem to travel slow relative to light. Like a spark is, you can see the spark. There's slow motion videos of lightning. You can see the lightning. I don't remember going up from the ground or into the ground, whichever, but you can see the slow motion of the electrons. They move relatively slow. A slow, like a normal camera, like a good camera can capture the motion of the lightning. It's not the speed of light. It's much slower. It's still pretty fast. So so they okay, so okay. So that's an electron. Now, as long as we're not observing, as long as they don't interact, they're waves. But how do they repel each other? Maybe as they interact, they appear to each other as particle during the interaction. Like they say that they exchange virtual photons, which are themselves waves or particles, depending on the interaction. So at the instant, I mean, so I have to trust at this point the quantum field theory. I never looked into it, but from what I understand, it explains electrons repelling each other and electrons and protons attracting each other. They actually use an ether like theory. The quantum field theory, the field is, I would say, the ether, but the people that talk about quantum field, they say there's an electron field, there's a photon field, there's a field for every elementary particle. I don't see how that could be possible because each field needs to be everywhere in the universe. And you can't have multiple fields overlaid at the same space. There can only be one field. So I would say there's just one field with just multiple properties that it can wave as an electron, it can wave as a photon, it can wave as a quark, it can wave as a Higgs particle. It can. So I would say it's the same. Are you following thus far?
Um,
Oh, you got lost? I lost you?
I get what you're saying. It's just
No, you need
it's
you
it's like convoluted. Not
no.
what you're saying. Like I understand what you're saying perfectly. It's just it's like why does it work like that? And you have so many questions. Like it brings more
I
questions than it does answers.
then ask the questions. Otherwise, I'll fall asleep. If I talk too much, I fall asleep. So ask me questions. What don't you understand what I said? Do you want like
I understand. Like, I understand it. It's just like the implications are just
like what?
it's like like so why
Hmm.
what dictates anything in the world is an electron because
What?
that it's
Wait.
basically like an on and off switch.
No, no, I didn't. I didn't say that. I didn't say it's an on and off switch. I'm first. I'm just noticing. Right. I just noticed a spark. Have you ever noticed a spark or a lightning?
Yeah.
Okay. All right. So right, that's how we begin science. We notice a phenomenon. Now we want to explain the phenomenon. So, what do you think is a spark?
Oh, so this goes into like the theory that like lightning struck a single cell amoeba and
No,
that
no, no, no,
gave birth to life.
no, no, no. We noticed the phenomenon of sparks. This is the scientific method according to Bacon. So you notice a phenomenon. That's the first step. The second step, you come up with an explanation. That's called a hypothesis.
And the hypothesis from seeing the sparks is
No, it's not the hypothesis from seeing the spark. It's what is your hypothesis? What is your explanation to the spark? How do you explain the spark? What is your explanation of the spark? What is it? What's causing us to observe a spark? That is a hypothesis. It is a scientific explanation. What is your explanation to the spark? When you touch the doorknob in the winter and you see the spark, what is that? What is that spark? What is that? Can right? That is the question, and the answer is the hypothesis, a scientific theory. What is your scientific theory of what just happened? Do you understand?
yeah.
So it's up to you. You have to come up with an explanation way before, I think, way before you contemplate the bonds between atoms to create molecules, I would start. I mean, you could start from multiple directions simultaneously, and may and build a puzzle, or build puzzle pieces, and then try to piece them together. As you try to piece them together, they're going to make more sense. You right. It's a very intricate puzzle game, jigsaw puzzle game. It's very complex, very intricate. So you need to build the puzzle pieces in your head, and then you need to put the puzzle pieces together in your head. It has to fit every experiment ever conducted, and uh, right? Do you understand?
So do you believe in like a theory of everything? Like, if we could we piece everything together and go like, this is that?
I'm trying.
Like,
I'm trying to piece it. That's exactly what I'm trying to do. But I think that's what every scientist is trying to do, whether they admit it or not. It's. I think like based like I think we have to, as I think that is the definition of science. Like, as scientists, we have to try and build a single scientific theory of everything. All the puzzle pieces need to fit together. So we've been able to put chemistry together with biology, together with physics, together with many things, but now we're stuck at the foundations of physics. People have been stuck for 100 years. I think since Einstein, people have been stuck. And I think it's because of Einstein. It's because of this worship of Einstein. People, I think Einstein overwhelmed the system. People, anyway, that's the psychology of what happened. But I think it's our, right? I think if we are scientists,
repeat that. What did Einstein say of the psychology?
no, no, I'm just saying Einstein, people seem to worship Einstein. People are afraid to go against Einstein. They're afraid to lose their job. They're afraid of being called hacks and hoaxes, because everybody wants to disprove Einstein to such an extent that in academia, I don't think anyone actually tries to do that, because they know that that's like saying aliens landed in my backyard. You're going to be considered a hack. So no one actually tries to disprove Einstein. Everybody's really terrified of speaking against Einstein, saying Einstein. To say that Einstein did not understand relativity is akin to what do you call it when somebody speaks against God?
Heresy.
Heresy and stuff like that. Yeah. So let's continue. So yeah, I'm trying to put together, of course, a theory of everything. Ether seems to lend itself to fixing relativity with quantum mechanics very nicely. So I think that's a good direction. I'm very happy with the progress I'm making using the ether model, the ether theory. Do you have any questions?
So, are bonds real?
I
Like, do
I,
they exist?
I don't see why not. I mean, I mean we know there is, right. We're here. We're functioning. Look, I didn't look into chemistry. I didn't look into physical bonds. So I have to refer to the experts, to the people who have looked at it. So for now, I'm going to accept their opinion, just like I used to accept Einstein. Now I no longer do. I mean, I accept some of what he said, and some of what he said I don't accept. I know where he's wrong, where he's right about many things. So, like, as long as I didn't look into something, I defer to the experts. After I look at stuff many times, I no longer defer to the experts. I say the experts are wrong. The experts are hacks. Sometimes.
Is there an equivalent of that in chemistry?
That what? I
Like,
didn't
is
look
there?
at what?
Okay.
I didn't look into enough into chemistry at this point to say. I mean, I don't see an issue right now with the table of elements. I don't see a problem off the bat with the table of elements. I don't see an issue. They seem fine. I mean, the explanation that there is atomic numbers and neutrons and an electron cloud and Schrodinger's equation that explains the electron cloud and predicted the electron cloud. And I think we've seen electron clouds in microscopes or something and stuff like that. So a lot of the details of quantum mechanics have been confirmed. I haven't seen any contradictions at that level. So quantum mechanics seems to be, I wouldn't call it a theory so much, but it's tiny theories that seem to fit together okay. Not very scientific. They're still Quantum mechanics seems to not be very scientific, but it's getting there. Hopefully, I'll have something to say about it. I already have a lot to say about it, but only good things, not bad things. Like I never, I never liked quantum mechanics. I always hated it until the day I realized that the ether is the best explanation for gravity and that everything is a wave, and that's quantum wave theory. So, and on that day, I started loving quantum mechanics. Until that day, I hated it, absolutely hated it. But now I absolutely love it, and I'm willing to accept literally every quantum mechanical experiment that I always said I don't believe it. I don't believe it. I never believed any experiment. I always said I want to see it. So since I never saw any quantum mechanical experiment, I could always deny it. But now I can accept it, and actually I can predict it. I can somewhat. Like the double slit experiment is predictable if you assume the ether liquid theory of gravity. Immediately you get the double slit experiment predicted. So I'm happy with that. Anyway, do you have any questions? Any more questions?
No, I'll let you
No, I mean you
continue
can
with your.
repeat the same question. But I'll probably I'm not gonna give you I'm not gonna be able to give you a satisfactory answer about the bonds since I didn't look into. There's too much I need to look into. I'm trying to just look into the foundations of Einstein's relativity. I'm just trying to prove that. I already have a good interferometer experiment. I can predict. I could have predicted the Michelson-Morley experiment to be a null result. So, but they didn't ask me, so they, you know,
So, do you think the world's like there?
what? Do I think the world is
Like,
there? Yeah, yeah,
yeah.
sure.
Okay.
I think what you see is what you get. It's not what I think. I'm just assuming what you see is what you get. That is Occam's razor, and I like Occam's razor because if you don't accept Occam's razor, if you don't accept the simplest explanation, then you might as well go for the most complex explanation. The most complex explanation, there is no most complex. There's only one simplest explanation, but there's no most complex. With every complex explanation, I can always add one more complexity. I can always double the complexity. I can always create more complexity. I can always say the spark is electrons. Yeah, but it's happy electrons. It's both happy and sad and crying. And, I can always add more nonsense to complicate a theory. So that's no good. So that doesn't get me anywhere. So I might as well go with the least complex. Least complex gives me the intuition that it's more correct. But that's just the intuition. We don't know what actually happens. So we either go with with the simplest theory or the most complex or anything in between. But Occam Razor says go with the simplest, and I like that. So the simplest theory about the universe is what you see is what you get. There's no there's no
Can't
simulation. There's no God.
can't like
What?
can't like well, you sound like fatalist almost.
No. Well, I don't even know what a fatalist is. What is a
Well,
fatalist?
maybe not fatalist. You're just saying
Oh, determinist.
okay, determinist. Sure.
Yeah, I'm a determinist, but determinism has no impact on our lives because the future is unknown. Yeah, the universe is predetermined. That is my assumption. That is the scientific method. As far as I'm concerned, the scientific method is predeterministic completely. It's super predeterministic. I have to assume predeterminism. The universe, the multiverse, it's all predetermined to the T. But
All right.
we
Well,
don't. What?
I'll I'll let you go. Thank you
Why?
for
No,
the
no. I'll
insight.
just. No, I was going to finish the sentence. You don't want me to finish the sentence?
Oh, sorry. Yeah. Please finish the
No, it's
sentence.
for you. I'm saying this for you. If you don't want me to finish,
Okay.
maybe you're not following. So the point is, you said I'm a fatalist. So I don't know what a fatalist is. I'm a determinist, but
Sure.
but we still have freedom of choice because we just don't know the future. The future seems to be impossible to know. So because it's impossible to know, you might as well behave as if you have freedom of choice. We don't have freedom of choice because the universe is predetermined. We're just acting out life. We're acting out the universe. We're just actors. We're not even actors.
And
We are
and it could
characters.
be someone else's play. And
It's more than that. We are. Imagine you're watching a movie. The actors have long since died. Let's say a movie from 100 years ago, 50 years ago. The actors have long since died. Right? Would you say that the characters can now choose something as you're watching the movie? Can anything, right? Everything that is happening in the movie that you're watching has already been predetermined 50 years ago when the movie was last edited. That's what you're watching. You're watching, right, a predetermined movie, but you don't know what's going to happen. So it looks to you like everyone has freedom of choice. But that is life. Life is we're just a pre-recording of this universe. We're just acting it out. We're just acting it out. We don't have any freedom of choice. No more than the characters the in the digital display that you're watching. These people don't even exist. These are just two-dimensional, you know, pixels changing colors. They have no choice. The people in the movie don't have choice. They don't exist. These are actors that have been pre-recorded many years ago, and everything is predetermined in the movie you're watching. That is reality. Reality is a predetermined movie. But we are those characters in that predetermined, pre-recorded movie. But we don't know the future, so we might as well do whatever we feel like doing. I mean, it's really magical to think about that. That is borderline magic. That's borderline spiritual. We are not only are we creatures of ether, not only are we waves of ether, not only are we ethereal creatures, but as ethereal creatures, this universe is just a pre-recording, and we're just we are the pre-recording, but we don't know the future, so we might as well do whatever we feel like. But what we feel like has already been predetermined, and what we'll do has been predetermined. Yeah, but we don't know. We don't know the future, so who cares? Yeah, we know that the future is predetermined, but we don't know what it is. So might as well do what you want. So the universe behaves as if there is freedom of choice. For all intents and purposes, you have full freedom of choice. Anyway, it's really really confusing, but I think it's beautiful. Do you understand anything of what I said?
Yeah.
I think it's
So
amazing.
there probably isn't free will, but that doesn't matter because you're in the present, and 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 you have to go with the present and not the
Exactly.
past or future because you don't know the past or future.
Well, you
So
know
you might as well believe in free will.
you can know the past, but you cannot know the future. Your free will is not about the past, it's about the future. You just don't know the future. Like you don't know what you're gonna do in 2 seconds or in 2 minutes or in 2 years or you don't know. You have no idea what's gonna happen. What you're gonna do, you just don't know. Even though we're just part of a pre-recording. This pre-recording could be trillions and trillions and trillions of years old. I don't know how long it could be really, really long. And what the future, the next trillion years is already it's already pre-recorded. We don't, that is the scientific assumption. That is science. But also science is we don't know the future. We cannot know the future. I mean, it's not science. I mean, we've noticed because of Heisenberg in what do you call his principle of lack of knowledge, Heisenberg's inaccuracy,
Uncertainty.
uncertainty. Yeah, my brain is dead. Because of Heisenberg's uncertainty, we cannot know the future. Because of wave theory, because we are waves, and because of location and momentum of waves, location and motion of waves, that has to do with Fourier transforms. I'm just beginning to figure this out. So if Heisenberg's uncertainty principle is correct, then we cannot know the future. He might be wrong. I still the verdict is out. I just started looking into Heisenberg's uncertainty. But if Heisenberg's uncertainty, I mean, even without Heisenberg, we still have the measurement problem that by measuring you're changing. You cannot measure without changing. So either you follow Heisenberg's uncertainty or because of measurement uncertainty. So you cannot know the future. Either way, you cannot know. I don't see how you can know the future. Even if you had the knowledge of every particle, location, and motion at this instant. So because of Heisenberg, you cannot know the future. You cannot know anyway. You actually and because of no if somebody gave us the information of every particle's location and motion, if we had the true information, I think we could predict the future. We would need a very big computer, but the question is the computer would have to be part of that knowledge. So even then, because the computer would have to make predictions, but but the but 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 knowing anyway, even then, I don't think we can predict the future. So it looks like we can never know the future. Therefore, we might as well do whatever we want. Therefore, we might as well assume free will. Anyway, that's it. That's the end of my brain. Are you okay?
Yeah.
Thank you. You want to stay? You want to go? What do you want to do?
Uh, I don't really have any more questions, so I'll let you do the Einstein stuff with
Let me
your
see how
audience.
long we've been here. There's 5 people. We've been here for 2 hours. I don't want to lose anybody, but my brain is dying. I don't know what to do about it. I don't know why my brain is so dead today. I
Shot
slept
of tequila.
tequila. No, that's
You
gonna turn my brain into complete. Maybe I'll smoke something, a cigarette. I don't know what to do. Maybe I'll smoke. I don't know how to wake up my brain. I've never had this before. Like
have you ever
I
smoked uh, salvia?
Never smoked almost any. I smoked just, very few things in my life. Most of the times I did not enjoy smoking anything or doing any drugs. I never enjoyed any of those. The experiences were really unremarkable and boring, mostly. One time I was able to have an out of body experience. That was very eye opening. That changed my mind about how the brain works. That gave me a lot of insight in my brain research. Other than that, no. I just drink. I drink. I just smoke cigarettes and cigars, and that's enough fun for me. Like I take drugs are very hard on my system. Like when I take, it doesn't matter what, it completely messes me up. You can see, I'm just a little bit tired, and I'm already dysfunctioning. So my brain is very bad when it comes to functioning. But this never happened to me that I wake up and I'm already dysfunctioning. This never happened. I don't know what happened. Maybe I didn't sleep well. Oh, I know something happened in the middle of the night. My left arm was completely dead. I woke up with a completely dead left arm, which usually happens like I don't know how yeah, it happened because whatever. Anyway, sometimes it happens. You could lose, did you know you can lose a limb if it falls asleep and you don't wake up? You could cut off the blood supply to your limb and lose it. People have lost limbs like this. So I've heard. Did you know that?
Uh, yeah.
Oh,
I think
you
it
knew?
only work applies for like comas though.
No, I heard that it usually only happens to people who are drunk. Like if you're drunk and you fall asleep, then you're not gonna wake up because of a numb limb, and you would lose it. So you gotta be very careful when you go to sleep. Like settle in very comfortably. Put your arms by your sides. Don't like sleep on your back only. Straight. Look up. Don't hold anything. Right. Because you don't want to lose an arm. Like even now, I can feel my left arm a little bit numb from last night, just a little bit. So anyway, but I never had this problem of waking up and immediately my brain is already. Immediately I'm sleepy. This never happened to me. I don't know what's going on. Maybe I'll eat something. Maybe I'm just so old. I don't know. Maybe it's the diet. I'm on a very very long diet. I'm cutting calories. Maybe that's the reason. I don't know. I thought I would talk to you and it would wake me up. It woke me up just a little bit, but if I continue talking, I'm going to continue falling asleep. But
Yeah,
I
I'm
don't.
feeling the brain fog too. Is it like a brain fog for you?
Yeah, people complain about morning brain fog or something. Maybe it's because of my diet. There's not. I'm not getting enough. Oh, I'm not getting enough carbs because I cut all carbs.
Oh,
Maybe
that's
that's
no good.
yeah.
Like, are you doing keto?
Not really. I don't believe in keto. Like I'm just cutting calories, but because I'm cutting
It's
calories.
supposedly bad. Like, you need to eat carbs because if you don't and you only eat like protein, the fat builds up in your intestines and you can get a heart attack.
Oh
So eat carbs.
no, I have a
Yes.
little carbs, just a little bit. Like I'm eating like chicken fingers, which are it's like small schnitzels. I don't know if you know what a schnitzel is. So where I'm traveling, they have this thing. They're big on schnitzels. It's like chicken, fried chicken, but like schnitzel fingers are like strips of chicken fried with breadcrumbs and egg, whatever. So internally, it's a chicken. It's a breast of chicken. The
So it's like
size,
veal.
well, sure, veal and chicken look the same, So, but it's a strip. It's the size of a finger. Basically, it's a finger-sized strip of chicken breast and covered with
And like
breadcrumbs.
breadcrumbs and
Yeah,
like egg and yeah.
right. So then it's already pre-fried. So I just warm it on my air fryer. So the breadcrumbs is carbs, and quite a bit of it. It's probably like at least one slice of bread per day, or two slices of bread, I would think. Anyway, we dropped from 8 people to 4 people, so maybe I should just go eat, and maybe that will help. Anyway, man, I'll catch you later. Oh, we're up to 5 people. I'll catch you later, and I'll come back and stream some more because I gotta figure things out. Thanks for stopping by, man. You're the best.
All right.
All right,
See
man.
you.
I'll see you later. Okay, bye. All right, everybody. We're gonna stop here. I'll take a break, and we'll come back later. I'll eat something, and maybe I'll drink another cup of coffee. I don't know. All right. See you later, everyone. Bye.